Okay, so we are looking at some periodic table stuff here, some mass values, getting ready to convert into moles, which is very important for problem solving. We do that a lot, and so just some definitional stuff here. And so when you're looking at this, you see that we've got the A says amount of a substance. And so then we've got masses of elements are relative to the mass of one carbon 12. That just means that are they bigger or smaller than carbon 12? Not something super important to you. The next three things are important. So what I want you to kind of understand is that the atomic mass right here, then the molecular mass below it, and then down here, relative formula mass. These are a lot of names for similar concepts. And so what you want to write down for atomic mass or AR, remember the terminology could be a little different in IB because it's an international class. So you're going to see some language and vocabulary that might not be 100% like what you're used to seeing here. So the first thing is that atomic mass or AR, that is the same. You want to write this down. That's going to be the average mass of an element taking into account all of its isotopes. That's the average mass or the average atomic mass, which takes into consideration all of the isotopes. The average mass of an element that takes into consideration all of its isotopes. So what do I mean by all of its isotopes? Well, if we go over to the periodic table and we'll take a look over here, make this a bit bigger. So when you're looking at an element, so we can look at carbon real quick, 12.01. The number at the bottom there, that's that atomic mass or the average atomic mass is usually what I call it in my class. And so the reason it's a decimal, the reason that that's a decimal is that some carbons weigh 12, some carbons weigh 13, some carbons weigh 14. So you have different versions of carbon, and those different versions are called isotopes. So this number, that's the atomic mass or the average atomic mass. And we use that number quite a bit. Okay, so let's take a look back at the notes. We've got a couple more definitions. MR, capital M, lowercase r, molecular mass. That is going to be the mass of a molecule in grams per mole, mass of a molecule in grams per mole. So let me go over here to your to our board we've been using. I'm going to go ahead and make that a bit bigger. I'm going to zoom in on that. Go back to this. Give me a little space. Okay. So what do I mean when I say mass of a molecule in grams per mole? Well, most things that you guys are looking at, those are going to be groupings of elements. They're not going to be individual things. And so we're going to be looking at that here. And what do I mean by grams per mole? Okay, so go here. We've got our pen. And so let's say you have water. Water's easy because we all kind of know what water is. There's water. Okay, that's a molecule of water. So a molecule of water, each of the hydrogens weighs 1.01. You can see that on your periodic table. And then, of course, we have two of those. So then that would be 2.02 grams due to the hydrogen component. And then the oxygen component is going to be 16.00. And I am not making these up. If we go over to our periodic table, there's that 16.00 on oxygen right there. See that 16.00? And right over here, there's that hydrogen 1.01. So I have two of those and one of these. That's where I'm getting those numbers. I'm not making those up. Those are just something that you look up on your periodic table. So then we are going to take those two numbers, that 16.00 and that 2.02, we're going to add them up, and that's going to give us what we call the molecular mass. It's also called molar mass. It could also be called gram formula mass. And so those are some other numbers. And so that would be a value. We'll change our pen color here. That would be 18.02. And then this is what it looks like in IB, grams mole minus 1. So this is a good place to talk about this real quick. This, what the heck does that minus 1 mean? Like what are we talking about there? So what that minus 1 means is that we have a situation where this happens a lot in IB. They put all of the units in a line. So what that actually means is grams times mole minus 1. Well, when you see the mole minus 1, then what that's telling us is that the minus 1 means it's on the bottom of your unit. And so that's basically what that's telling us. So what that means is it means grams over moles. So see, that minus 1 just means it's on the bottom of the fraction. And so there's a little multiplication sign right there. So it's grams times moles minus 1. That minus 1 just means it's on the bottom. So it's just a unit. So anytime you see a negative exponent, it's putting it on the bottom. So grams per mole. It's just a fractional unit. And density is a fractional unit. So that's not, shouldn't be really weird. It's just a unit. So, okay, so that's the molecular mass. Now, the other things you might want to write down is that can be called, I've used this in class, that can be called molar mass. That's another term for the same thing. It can also be called gram formula mass, but the ones that I've given you are the ones that you're going to see in the IB textbook, in some of the homework, things like that. But they're really interchangeable. Molecular mass, molar mass, gram formula mass, and then formula mass are all very similar. Okay, so if we go, don't want to do that. If we go down here to D, it says relative formula mass. You just want to write down the same thing. You want to write down that that's the mass of a compound in grams per mole. So we're just talking some slight vocabulary differences. So here, this one here, get my highlighter. So this one here, C, molecular mass has the word molecule in it. So this is technically for molecules, where this one is formula. So you can use compounds or ionic compounds. And so the difference is that molecules are technically nonmetals, and formulas can include metals and nonmetals. That's really slight vocabulary differences. All you need to know is that to get these things, you add up how much they weigh on the periodic table. So let's go ahead and let's look right here at example 3, and let's go ahead and do some math. So you need to find these on the periodic table, and we're going to add them up. So I'll write this one out for you, and then I'll have you guys try a couple more. So on this one, I'm going to write this up here in the space above. You have 6 carbons. So first thing is we're going to look up carbon. We're going to find it on the periodic table, and carbon is right there. It weighs 12.01. So see that 12.01? That's how much that carbon weighs. So we're going to go ahead and we're going to pencil that in, and we're going to write, I'm going to put it up here. We're going to do 12, oops, can't do that. We're going to do 12.01, how much the carbon weighs, multiplied by 6, because we had 6 of them. Okay. And then we're going to add that to the hydrogen. So if you remember, I said the hydrogen weighs 1.01. We did that a minute ago, but I'll show you that again, just in case you have forgotten right here. There's that hydrogen, weighs 1.01. Again, you should be using this periodic table Shouldn't be using a different one. Use the one that I gave you because that makes sure that all of our answers are going to be the same. So 1.01, and we've got 12 of those. And then I'm going to add that to the last part, which is the oxygen. Now, if you remember, the oxygen weighed 16. You guys are probably going to memorize that because we use oxygen a lot, and oxygen is always going to weigh 16. So there's 16.00. So I'm not doing anything crazy, just getting it off the periodic table. So we're going to go 16.00 times 6. And so we're going to put all this in our calculator, and we're going to get a number. Now, I'm going to do this right now. Plug it in, 12.01 times 6, enter. I'm going to add that to in parentheses. Don't forget your parentheses, guys. I got them there. You should probably use them. Your calculator has them. And then I'm going to add that to in parentheses, the 16.00 times the 6. And there we go. We hit enter, and we get 180.18. We're not going to do anything with sig figs on these. When you're doing stuff with periodic table values, we're just going to use them as is. So that's going to be 180.18 grams mole minus 1. Okay, so I want you guys to practice on example 4. Add those up. See if you get those right. I'll help you out a little bit here with the formulas just in case I don't want you to get them wrong. So phosphorus pentafluoride. Think about the penta. What does that mean? Dinitrogen tetraoxide. What do the prefixes mean? And then I gave you some formulas there. So I'm going to pause this here. Okay, so you should have paused this. You should have tried these on your own. I'm going to give you guys the answers on these. You're simply looking the parts up and adding them up. So the phosphorus pentafluoride would be P, and then fluorine is F, and that's a 5. And then the mass on that is going to be 125.97 grams per mole. So that's going to be the same for all of them. They're all going to be grams per mole. Dinitrogen tetraoxide means you have 2 nitrogens. That's the di. And you've got 4 oxygens. No crisscrossing because, see, we're using prefixes. So with the prefixes, there's no crisscrossing. So if I add that up, 92.02, 92.02, also grams per mole. Kind of running out of space there. And ammonium perchlorate, that was a long one. 1 nitrogen, 4 hydrogens, 1 chlorine, and 4 oxygens. That one is 117.50 grams per mole. And the last one, chromium sulfate, going to sneak that in here at the bottom. Make sure you have the right formula. So chromium is going to get a 2 from the sulfate, and the sulfate is SO4, and it gets a 3. So there's your formula. You need to use your periodic table for that. And I get 392.21. All right, guys, going to pause it here.